Okay, now today we're going to be doing two lessons, but they're both what I would consider um, quite easy. Now, I say that obviously with danger because you're like, oh, if I don't get it, I'm going to be stupid. You said it was easy. But you're going to find that today we're not going to be doing any factoring. We're going to be using 100% common sense to be able to do these questions that you've been doing with your calculator, with all of these synthetic division, all that. Today we're just going to talk about characteristics. Now this is right out of Pure 20. Okay? And it kind of is more fitting now in 30 because we're doing all these graphs. Maybe we should kind of know something. So when I do get a graph, does that even make sense? Okay? Now the first thing we're going to talk about is the thing that I have been repeating over and over and over again. And these are all equal, right? Zeros equal roots equal x-intercepts. Now, we always have to know that because they shouldn't just interchange a word on us and now we're all messed up. Oh man, I know how to find zeros, but I don't know how to find x-intercepts, okay? So, keep those straight. And what is kind of opposite of that is when we're finding the factors. Because if the 0 is 2, the factor is x minus 2. Okay? So remember, 0 equal roots equals x-intercepts is almost equals opposite factors. Okay? I would keep those in mind. And today you're going to learn a fancy name for something you've known all along. Now, the unique factorization theory is, basically, whenever you factor, you're going to get something like this. And we just did that on the last quiz we wrote. Now, basically, there's 2 points to it. And like point 1 is, it's not ground shaking. Every polynomial can be written as a product of its factors and a leading coefficient. Okay? So you've always known that. Number 2 maybe is a little bit more important, that every polynomial function has the same number of factors as its degree. So if you had x to the 4, plus or minus, ... there will be 4 factors. And that kind of should make sense, because how are you going to get x to the 4th if you don't have an x minus 2 times an x minus 3 times an x plus 4 times an x plus 5 to get those 4 x's to multiply to get x to the 4th? Okay? So, I don't know if that's even news to you, but it is part of the unique factorization theory. So they can all be written as that sentence right here. And if it's x to the 4, look for 4 factors. If it's x to the 12, look for 12 factors. Okay? Now, if the leading coefficient is positive or negative, that gives a lot of evidence of how this graph should be. Now, let's just look at this graph right here, because this kind of is 100% review. You could probably have done this exact question in grade 10. So, what would be the zeros of this polynomial? So, minus 2, 1, and 3. Okay? State the factors. What would be the factors? X plus 2, x minus 1, and x minus 3. So what would the polynomial be? P of x equals x plus 2, x minus 1, and x minus 3. Okay, now this is what I'm talking about. Do you see how it's an x cubed? So there should be 3 factors, okay? Oops, it's supposed to be a 2. Now, I bet you could have done that question in grade 10. Okay, but remember, zeros equal roots equals x-intercepts, and they're all opposite factors. Okay, that sentence should be somewhere on a study sheet, because you don't want to mix that up. Okay, now, if you were to graph this, let's do that now. Okay, I just want you to graph this into your calculator into y1. And y2 0. Okay, so I'm just putting in negative x cubed plus 4x squared plus 7x minus 10. Okay, now how many times do you think it should go through that x-axis? 3 times, okay? 1, 2, I put something in wrong. I can tell you already. I got 3 though. That's pretty good. 4x squared plus 7x. Negative x cubed plus 4x squared. Oh, you know what's wrong? I did put it in right. I just had different window settings. Okay, now I'm not seeing my top and bottom very well. So I'll hit my window and I'm just going to do negative 20 and 20s on here. Oops. Okay, much better. Okay, so we're just going to draw that here. Okay, now, what are the x-intercepts? Negative 2, 1, and 5. Okay, so I'm going to write those down. It says what state the x-intercepts? Negative 2, 1, and 5. So the polynomial p of x equals, what would it be? X plus 2, x minus 1, x minus 5. Okay, now put that into y2 and make sure that it's right. Okay, and you should get the same graph. Are you getting the same graph? You're not getting the same graph. Okay, so that, we were all comfortable with this. We're like, okay, this makes sense. I'm good to go, right on. Let's do it again. Whoa, it doesn't work. Why doesn't it work? See, there's a negative here, so there better be a negative there. Okay? So you probably all had a reflection of this, which makes sense, because if you take the negative out, that is a reflection in the x-axis, right? Because that negative can go with the y. Now, instead of filling all this out, I'm going to now give you all the rules on, well, half the rules, because then we're going to go to lesson 8 and show you the other part. But here's some things that I want to talk about. Now, over here on the side, I want you to write even degree. Now, things of even degree would be x squared, x to the 4, x to the 6, dot, 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 right? Those would be considered graphs of even degree. Now, just draw a graph underneath. I'm going to give you all the rules that you need to know on where to start and where to end. Now, if you have an even degree that is positive in the front, so even degree positive will always start in 2 and end in 1. So it will always start in quadrant 2 and end in 1. So an even degree positive, and I'm talking about that positive constant in the front, will always give even degree and, will always give starting in 2, ending in 1. Now, if it is an even degree negative, it will always start in, so if it's negative, it will always start in 3 and end in 4. That's always, okay? Now, I'm at the diploma. I'm stressed out, okay? I get to this question, and it says, even degree negative will always start in quadrant what and end in quadrant what. Add the two sums together, put it in numerical response here. And you're like, crap. Oh, man, I forget. How on earth are you going to find that out? Couldn't you do that question if you forget? How? Graph anything. Okay? If it's x to the 4, x to the 6, put negative x to the 6. If it's negative even, which quadrant would it start and end? Okay? You just have to put that into your calculator and put up like 3x to the 4, negative 3x to the 4, minus 2x squared, whatever. See where it ends. You could do 100 of those and you will get the pattern going, oh yeah, it always starts here, ends here. I would probably try 3 of them. Okay, just to make sure that's right. Now, let's talk about odd degree. Now, odd degree, what am I talking about? Odd degree, well, x cubed, x to the 5, those are odd degree. Okay, so draw your graph, and if it is positive and odd, it will always start in, so positive will always start in quadrant 3 and end in quadrant 1. So hopefully you have different colored pens, because maybe if you have yours in pencil, this is going to like look pretty weird when you try to, or maybe you'll just remember these notes. Okay? Now, if it is odd degree negative, it will always start in 2 and end in 4. Okay, so instead of giving you a bunch of sentences and notes, I've summed it up all right here. So we're not even going to do D because D is just confusing. So if you know, if it's even, positive, now you can also say it starts high, ends high. Okay, by high I mean above the x-axis. Below always means below the x-axis. Okay, it's a really complicated system. So if it is odd degree, positive, it'll start low, end high. Or start in 3, end in 1. Okay? So I'll just give you the assignment for that. You're doing 1 and 2. ACE for those. And 3 all. Okay, let's open the next lesson. 1 and 2 ACE, 3 all. ACE, yeah, is there G's? No, ACGI, ... That's supposed to be a ... Okay, ACE ... Okay, now 8 is just a continuation of, because I've always taught 7 and 8 together, because they kind of, if you know all of it, it's just one complete package, right? Now, if you look at this equation here, that's x plus 1 times x minus 3 squared. Now here is x plus 1 goes through 1, and what is it doing at 3? It just touches it, right? Now, if you want to explain these behaviors, now, whenever I go through these lessons, I don't look at the most complicated way to get you guys to remember this. I try to think of the simplest thing. So, this is the factor x plus 1. This is the factor x minus 3 squared. Now, what does a squared do to the graph at the x-axis? Okay? Now, when you're thinking of how to describe this, I need you to be able to get a 5-year-old to understand what you're saying. So don't use words like tangent and stuff, because a 5-year-old, you'd have to teach them what tangent is. Okay? And that's a whole other, next thing you're off on some other tangent, trying to explain it, and you forget where you are. Okay? I just made that up right now. I've never used that before. Now, what is happening at that? It is a positive right from the beginning, right? Because it does start in 3 and end in 1. How would you describe what's happening there? To a 5-year-old, remember. What if that was a ball? What would it be doing? Bouncing. So whenever you have an x squared, tell them whenever you have an x squared, it will always bounce. Okay? So an x squared will always bounce. Now that's called the multiplicity of 2. A multiplicity of 2 will always cause a bounce, okay? That's a very complicated way of saying x squared, but that is a multiplicity of 2. Will always bounce. Now, what does a multiplicity of 1 always do? Goes through, okay? Remember, think like you're talking to a 5-year-old when you do this. He would understand that. It goes through. If it's to the 1, it's going to go through. If it's to the 2, it's going to bounce at that point. And whenever you have x cubed, so say you have x minus 3 cubed, it will do, say it's going to go like this. It'll do something like that. That is a multiplicity of 3. It would do that. Now, to a 5-year-old, how would you describe that? It's not easy, is it? When you're trying to explain things to a 5-year-old, it's much harder than a 20-year-old. Okay? So the challenge is, how would you just tell a 5-year-old? It always does this here. Bounce he's going to get. Okay, I got bounce now. Waterfall. It does a waterfall. Makes a ledge. Okay. I have come up with the highly technical word. It does a squiggle. A 5-year-old will be like, oh, squiggle. Okay, got it. Okay. So if it's a 1, multiplicity 1 goes through. Multiplicity 2, it always bounces. Multiplicity 3, it always does a squiggle. Okay? Now, the technical words of these are when it's a tangent, x plus or minus b squared, it's always a tangent, aka a bounce. Okay? So just so you know, tangent is a bounce. And then the technical word of when it's going through, it's called points of inflection. So that would be x plus or minus b cubed, which is called a squiggle. So now we have to take all of lesson 7 and all of lesson 8 and try and do a question. Now, here is the entire question right here. I want you to look at example 1. Now this is the entire polynomial, and they have factored it for us. I want us to be able to draw this entire thing without looking at our calculator. Okay? So can we draw this? Now the first thing you have to look is the degree. Is it even or is it odd? So what is, we have, I want you to write all of these things. These are, we got even degree. Positive or negative? It is positive. What always happens with even degree positive? Starts high, ends high. Starts in 2, ends in 1. Okay? So we need to know that it's going to start here and finish here. So all we're doing is gathering evidence that you probably didn't even know existed half an hour ago. Okay? Now you can always know where it starts, where it ends. Now, what's happening? So I'm going back to this. We have these very significant points. What points are these on the graph? Going left to right, what point is this trying to describe? Minus 3. So over here, go minus 3. What's the next point? Negative 1, and the next point? 2. Okay. Now, let's go here and just write underneath what is happening at this point. Going through. Okay, so this is a through. What's happening at this point at x plus 1 squared? Bounce. Add at x minus 3, or x minus 2 cubed. No one even wants to say it out loud. What's happening there? A squiggle. Now, I need you to graph this right now. It must start in 2, finish in 1, has to go through 3, squiggle or bounce at negative 1, and squiggle at 2. Draw your graph. We should all have the identical graph if you gather all that information correctly. Graph. Let's go. Now, probably the question you're asking right now, well, how, like, when I do my little, like, up-down things, how low should I go, we don't care about that right now. Okay? So, this is what should be happening. I need to start here. I should be going through, and then I know I got to come back. And what am I going to do here? I'm going to bounce, and then I'm going to come here, and then I will do a squiggle. That's what should be happening. Okay? So, come here. I don't care how low I have to go. I'm going to bounce, and I'm going to come through here and do a squiggle. Okay? And we can graph it, and you're going to see it's going to look like that. So, just so you know, this would have multiplicity of 1. This is multiplicity of 2. And this is multiplicity of 3. So multiplicity of 1, that we've always said is a through. Multiplicity of 2 is always a bounce. Now what is the technical word for bounce? Tangent. Okay? Multiplicity of 3, we always said is a squiggle. It's been like 5 minutes, but squiggle. And what's the technical term for that? Point of inflection. Okay, so you can imagine how the homework's going to go today. It's going to go quite quick if you know all of this stuff at once. Okay? So let's just go and let's come up with the answer to this one without doing all the factoring. Okay, so I want everybody just to put that into their graphing calculator. And you see the window settings here. That's why mine were all messed up last time, because I used these. So I want you to put these window settings in after you, or before, it doesn't matter. Okay, so let's put in x fourth plus 2x cubed minus 15x squared minus 32x minus 16. Okay, and then look at it one more time. Make sure you got it right. 2x squared minus 15x. I don't have my squared. It should be a squared. Minus 32x minus 16. So window, negative 6, 6, 1, and negative 150, 100, and 20. And graph. Okay. So try and draw this over here, because the graph is kind of important. Now, how many roots would there be? Technically, how many will there be? 4, right? Now, again, to people that don't know what's going on, they would say, no, there's only 3 here. Okay? There is this point here. Oops, I'll do it in red. That's 1, 2, 3. Okay? There's only 3 zeros. There's only 3 x-intercepts. Now, what are those x-intercepts? What's the first one, going left to right? Negative 4. This would be negative 1. And this would be 4. Okay? Now, at 4, what's the multiplicity? So this would be a mult of 1. At negative 1 would be a multiplicity of 2 or 3? 2. And this would be, at the 4 would be multiplicity of 1. So if I was to come up with my equation in this form, now here's a question that could be on numerical response, quite easy, and it would just ask, put the value of c in. That's all they want. Now, you may sit there and go, but anyone can go in there. No, there's only one c squared. Okay? A and B, you have your choice. But there's only one c. Okay? So, p of x equals x minus negative 4, so x plus 4. And then I'll put x minus 4, and since that's multiplicity 2, that would be x plus 1 squared. So the value of c would be actually negative 1. But, okay? Now, remember, multiplicity of 2 is your bounds, right? Multiplicity of 1 is through on both of those. And remember, your bounds, the same thing as tangent. A squiggle is your point of inflection. Does this make sense? Okay? So it's pretty fast questions. all or most of you will get your homework done at class. So we're doing 1 to 3, 5 to 7, 12, just do II, and 13 to 15. And do a nice job of summing these rules up on your study sheet. Again, in 3 months from now, you will find that invaluable just to be able to read over those rules and get it all back. Because I'm assuming they will have one question in the diploma on those rules. Now, you don't have to memorize them, but you really need to know them.